Okay, imagine you're holding your mouse, you click a folder, and, it opens. Instant response.
Of course.
Now imagine the actual computer you're controlling isn't under your desk.
Mm-hmm.
It's not even in the same building. It's almost 2 miles away. We're talking 9,842 feet.
That sounds like a complete nightmare for lag. I mean, usually you run a copper cable more than a few hundred feet and the signal just dies.
It usually does, yeah. But today we're unpacking a device that claims to completely break that rule. We're looking at the NTI ST-IPFOUSB4K-L-LCVW.
That's a catchy name.
Let's just call it the NTI Fiber Extender. Our mission for this deep dive is to figure out how this thing uses fiber optics to let you control a high-performance machine from what is basically a 30-minute walk away without it feeling like a slideshow.
And control really is the key word here. This is a KVM extender, keyboard, video, mouse. So you're not just streaming a video. You're actually interacting with the OS. If there's latency, it's unusable.
So let's get into the distance claims first. The specs say if you use single-mode 9-micron fiber, you get that full 3,000 meters.
Right.
But with multi-mode 50-micron fiber, it drops to about 550 meters. So for anyone who isn't a network engineer, why the huge gap?
It all comes down to how the light travels.
Okay.
Think of single-mode fiber as a very, very narrow tunnel. You have a laser pointing straight down the middle.
Okay.
The light barely bounces, so it keeps its integrity over miles. Multimode is, well, it's a wider tunnel using a less focused LED light. The light bounces off the walls. We call that modal dispersion. And that degrades the signal way faster.
Okay, so single mode is the sniper rifle. Multimode is more like the shotgun.
That's a pretty good way to put it, yeah.
But even at 550 meters, that's still multiple football fields. My question is, does the picture quality actually survive that trip? Or are we just looking at a pixelated mess by the time it gets to you?
The specs insist it holds up perfectly. It supports full Ultra HD 4K resolutions. That's 3840 by 2160 at 30 hertz. And it also keeps all the high-end audio like Dolby True HD and DTS HD. But there's a little detail in the fine print that really tells you who this is for.
What's that?
TAA compliance.
That's the Trade Agreements Act, right?
Exactly. It means this hardware is cleared for U.S. government use. This isn't built for a casual gamer. It's built for a secure server vault. You lock the actual computer in a blast-proof room underground, and the analyst sneaks in a nice, sunny office blocks away with zero loss in fidelity.
That makes a lot of sense. But I'm looking at the setup guide, and this isn't just a really long extension cord. It talks about connecting through gigabit SFP switches. That sounds like networking gear.
It is, and that's a total game changer. Because the signal is converted to IP packets, you aren't limited to just a straight line, point to point.
So you can use a switch.
You can plug these into a managed network switch and do point-to-many or even many-to-many setups.
But wait, hang on. If I have many-to-many, that implies multiple people could be trying to control the same computer. Wouldn't they just be fighting over the mouse cursor?
They could be, yes. Which is why the device has two different USB control modes. First, there's exclusive mode.
One person at a time.
One person drives, exactly, keeps the peace. But then you have USB sharing mode. This lets multiple remote units share control of the source machine. It can recognize up to 5 different USB devices at once.
So you're saying I could be typing, and you could be clicking the mouse.
Yeah.
And we're sitting in completely different buildings.
Yes. It transforms the device from just a security tool into a genuine real-time collaboration tool.
Okay, so on the flip side of that, what if I want to send one computer signal to a lot of screens? I see the source mentions video walls.
It's surprisingly robust there. You can support configurations from a simple 1x2 setup all the way up to a massive 8x16 array.
An 8x16. That's 128 screens. That's a billboard.
It's huge, and it's flexible, too. You can even rotate the displays 180 or 270 degrees. It handles all of this using something called VLANs on the switch.
VLANs.
Virtual Local Area Networks. Think of them as dedicated lanes on a highway. The switch makes sure the little slice of the video meant for the top left screen only goes to that screen. It keeps all the traffic organized so the network doesn't just choke.
And is this something a normal person can set up, or do I need a full IT degree here?
For a direct point-to-point connection, it's plug and play. The receiver just finds the transmitter automatically. But if you're building that 128-screen video wall,
I'm guessing that's not plug and play.
You're going to need to log into the web interface for that. It's not quite magic.
Fair enough. So to sum it up, for around $620, you get a device that effectively just deletes physical distance as a constraint for high-performance computing.
It completely uncouples the workstation from the worker.
Which brings up a really weird thought to end on. We're used to the cloud, where data is just
Hmm.
everywhere. But this is a physical piece of hardware.
Right, a specific machine.
So if this USB sharing mode works perfectly over miles of fiber, and 5 people can control the exact same secure machine from 5 different buildings all at the same time, to the very concept of a personal computer basically just disappear.
Hmm. If the computer is everywhere at once, is it really yours anymore?
Something to think about.
Eh.
Thanks for joining us for this deep dive.